Okay. So you want to differentiate this function. I hope you all know that what you do is differentiate this power function. So it's going to be 5x cubed minus 1 to the power of 4. Is that the end, or is there something else? Yeah, there is inside. Yes, so we need to differentiate the inside of the function, which is going to be 3x squared. So what you are doing here is an example of the chain rule, basically. You are using the chain rule, where you are differentiating a function f, yeah, y equal to f of a function u. Then if you want dy over dx, then it's going to be basically the derivative of f with respect to u, which is what we have here. And then you need to multiply that by du over dx. And what you're getting here is basically the chain rule with one variable. The same idea exists for two variables and three variables, etc. So let's have a look at what happens with two variables. You have the rule here. So you have a function z, which is a function of x, okay, and y. And x itself is a function of t, and y is a function of t. So how do we get from here? How do we get the derivative of z with respect to t? Well, you need to use this rule. So it's dz over dx multiplied by dx over dt plus dz over dy multiplied by dy over dt. This is the chain rule with two variables, x and y, which are both functions of another variable t, like here. Yeah. So let's see in this example. Okay. So we have okay, z, or function f, basically is given here, x squared e to the power of y, and I want to find the derivative of the function, let's say, so it's dz over dt. So I want to find dz over dt. Z here is x squared e to the power of y, like this. So if you look at this rule, how many things do we need to find here? If you look at this rule, the chain rule with these two variables x and y, each one a function of t. If I want dz over dt, so can you see how many things we need to calculate? How many things we need to find? 1, 2, yes, actually 4, yeah? You can see that there are 4 things that we need to find here. So dz over dt will be, so let me write the rule here. So it will be dz over dx multiplied by dx over dt, and then plus dz over dy multiplied by dy over dt. So we have 4 things to calculate. Z is here. X is given. T squared minus 1. Y is also given. So let's just calculate this. What is dz over dx, girls? What is the derivative of z with respect to x? Can you tell me? No, dz, z. Can you look at z here? What is its derivative with respect to x? Thank you, Noor. Yes. So it's going to be 2x e to the power of y. So this is the dz over dx. Multiply by dx over dt. Here is x. 2t, thank you, yes, 2t. Plus dz over dy. What is dz over dy? Look at z. Yeah, x squared, thank you. X squared e to the power of y. Multiply by the fourth term, dy over dt. What is dy over dt? Y is, yeah, cosine t. Come on, girls. You need to participate a little bit. After this, because we want our final answer to be a function of t, then I need to substitute. So it's going to be 2 times x, which is t squared minus 1, e to the power of y, which is sine t. I think I will just, yeah, multiply by, yeah, sorry, multiply by the 2t, yeah, multiply by 2t plus x squared, so it's going to be, yeah, mm. So I will replace x with its expression, t squared minus 1, okay, squared, e to the power of sine t, yeah, cosine t. What have, from here to here, or what? Or, yes, what is x? X is here, yeah? Replace it with t squared minus 1. That's it. Substitute now because we want our final answer only with t only. You want your function, your final answer just as a function of t, the variable t. That's it. We don't want x, y, t at this. So here, once you have this result, you substitute x with t squared minus 1, and the y is sine t. So just replace, substitute, and you will get this. Does that make, is it okay? Or yeah. So here, just put x, every x is t squared minus 1, and y is sine t. Just substitute, and you will get the final answer will be this expression here. So that is basically the chain rule where you have a function z, which is a function of x and y, and x and y themselves are functions of t. So you have z here, you have x as a function of t, y as a function of t. So you want to find dz over dt, then you need to use this formula, the chain rule. Okay. Now, here we have another situation now where basically z is again a function of x and y, but x is a function of two variables, not just t. It's actually a function of s and t. And y is also a function of s and t. So here we have two independent variables, s and t. How do we get the derivative of z with respect to s? So you use this rule, and the derivative of z with respect to t, you need to use this rule. So that's the second rule for this chain rule. So let me just consider, yeah, this example. Okay, so let me see if I can get, yeah. Uh, okay, here z is exy. X is a function of two variables uv, so it's 3u, and y, function of two variables for v squared times u. So we have this situation. And I want to find now what is dz over du. So what we're going to say is that it's dz over dx multiplied by dx over du plus dz over dy multiplied by dy over du. So that is the derivative of z with respect to u. Now, it's just a matter of calculating each one of these. Yeah. Yeah. Yes, sine v. Yes. Sorry. Yes. Sine v. Okay. So we need to calculate again four terms: 1, 2, 3, and 4. What is the first one? dz over dx. I think we can calculate each one of these without too many problems here. So dz over dx. So here is z. You want to find its derivative with respect to x. So remember, y is a constant. So the derivative of xy with respect to x is y. So you need to have a y at the beginning. exy multiply by. So this is dz over dx. What is dx over du? Now look now at the function x. What is its derivative with respect to u? 3 sine v. Yes, thank you. 3 sine v plus, okay, dz over dy now. Okay, the derivative of z with respect to y will be x exy, and then multiply that by the derivative of y with respect to u also. Yeah. Derivative of y with respect to u will be, what do you think that will be? For v squared. Yes, like this. Okay, good. After that, yeah, yes, Salha. dx over du, yeah? The derivative of 3u sine v with respect to u, yeah? X. Can you see x here? x is 3u sine v. Yeah, remember 3 sine v, this is x, yes? 3 sine v multiplied by u, like this, yeah? It's 3 sine v multiplied by u. It's a bit like when you want the derivative of 5x. What is the derivative of 5x? Do you need to use the product rule here? Do you need the product rule? No, because 5 is a constant. So its derivative is 5. خلاص. Same thing here. This is a constant. 3 sine v is a constant. There is no u there. So the derivative is 3 sine v only. Do you understand this? Yeah. So no need for the product rule here because this is a constant, so no need for that. Now, okay, what's the last step here, girls? What do we need to do at the last step? There is another step here, which is substitute, yes. So I need now, your final answer here should be a function of u and v only. So I need to substitute. So you will get, so let me write that. We substitute. So it's going to give us y, which is 4 v squared u multiplied by x is 3u sine v multiplied by the y, which is 4 v squared u. Multiply all of this by 3 sine v plus the x again is 3u sine v. This is not an easy thing to write, but I will write it anyway. 3u sine v times y, which is 4 v squared u, and then multiply this by 4 v squared, and all of this is basically the final answer. It's not very pretty, but that's how you do it. I will not do they're asking us for also to do dz over dv. I will just write the rule here. So now if you want dz over dv, then the chain rule says that it's going to be dz over dx multiplied by dx over dv, good, plus what? dz over dy multiplied by dy over dv, and that is the chain rule again, but this time with the variable v, and you can do exactly the same. So you can try it. I will leave it to you to have a look. Okay, I will not really insist too much on this chain rule. It's a really messy thing. But a few examples in it. I will just do one more here. This time we have a function f of xy like that, and x is a function of r and theta. So r cosine theta, y is r sine theta, like this. And what we want is to find fr, which means the derivative of z with respect to r. Okay. Uh, by the chain rule, I can use the chain rule again. So it's going to be dz over dx multiplied by what? Dx over dr, yeah? Plus dz over dy multiplied by dy over dr. So this is what the chain rule says. And then I need to apply it. So dz over dx, I can just write it because I don't know what the function is. So it's just the function of f with respect, the derivative of f with respect to x. And then dx over dr, what is the derivative of x with respect to r? If you look at x and you differentiate it with respect to r, what will be the answer? So look at this x and differentiate it with respect to r. Cosine, yeah? You will get the cosine theta. And then plus, yeah, thank you, plus dz over dy. Again, we don't know what this function z is, so I will just write it as the derivative of f with respect to y that I multiply by dy over dr, so which is the sine theta like this. So we're getting exactly what we want, which is this rule here. Show that the derivative of f with respect to r, f or z, same thing, is given by this formula, and that's okay. Right, that's basically some examples of this chain rule with two variables and the way it works. Um, not easy as such, but actually the important thing in this section is this idea of implicit differentiation, which comes often in tests and exams. And this one is really simple. So what happens is in implicit differentiation, suppose you have a function f of xy equal to 0, like this. Yeah. For example, you have x squared minus 3y squared is equal to 0. This means that y is a function of x, but it's not given explicitly. So y is a function of x. So we want to use this equation to find what is dy over dx. Well, here is the rule. dy over dx will be minus fx over fy. So you want to find dy over dx. So it's going to be minus fx over fy. That means the derivative of this is the function f. What is fx in this case? The derivative of this function f with respect to x. You can see that if you differentiate this with respect to x, you will get 2x. And then divide that by fy, which will be 6y. So the derivative of y with respect to x will be minus x over 3y, like this. So that is what we call implicit differentiation. So this is the first rule you need to memorize here. If we have three variables, x, y, z, and you want dz over dx and dz over dy, then the rules are here. Dz over dx is minus fx over fz, and dz over dy is minus fy over fz. So that is, yeah. Okay. So let me just consider, yes. All right. So here is an example with the three variables. So I want dz over dx. The rule says that this will be minus fx over fz, like this. Okay. So now we need to find these two things. The derivative of this function with respect to x, and we also need the derivative with respect to z. So let's differentiate the function f with respect to x. Can we have some answers here? What is fx? Can you try? Y squared, yeah, y squared. Uh, where? Oh, here. Yeah, oh, in this example, fy, yes, fy is minus, yes. Yeah, and it becomes plus, yes, thank you. Yes, exactly. Yeah, we have two minuses, so we get a plus in the end, yes. Okay, yeah. All right, so thank you there. So we have fx. It's going to be y squared, which comes from here. This will give us 0. And the derivative of this with respect to x. So you need to differentiate the inside. The inside will be, with respect to x, it's yz. Yes, yz cosine x, y, z. Yes, like this. Over the derivative with respect to z. So with respect to z, we will get 3z squared. Yeah. Plus, what do you think? Yeah, xy, yeah, xy cosine x, y, z. That's it. So that's the derivative of z with respect to x. Although we don't know what the function z is, but we know its derivative will be this one. In the same way, we can find the dz over dy. The rule now will be minus fy over fz, like this. So we're going to do the same work. Fy, the derivative of this function f with respect to y will be, so the first term will give us 2xy, and then the sine term will give us the sine term derivative with respect to y will give us xz cosine x, y, yeah, z, like this. Okay. And the denominator, we already have it. We already calculated it before. So it will be 3z squared plus xy cosine x, y, z, like this. So these are the two derivatives that we are after. Yeah. All right, so let's have a look at some of these questions. Here we have a function of two variables, x and y. So you can write this as z equal x squared y minus sine y. X is a function of t, and y is also a function of t. So I can find the derivative of z with respect to t. So I want g dash, which is dz over dt. So the rule says this will be dz over dx multiplied by dx over dt plus dz over dy multiplied by dy over dt. So again, we have four things we need to find. Okay, then good. So let's do this. So what is dz over dx? Two xy, yeah, that's it. Two xy's, huh? There's nothing else. Two xy. Multiply by dx over dt. Okay, the derivative of this, I will give it to you. You can calculate it. There are different ways of doing that. It's going to be basically t, yeah, over, yes, square root of t squared plus 1. Yes. Plus, you can check that if you want. Plus dz over dy. So the derivative of z with respect to y, we will get the x squared. No, look at z. Look at z, and you need to find its derivative with respect to y. So it's going to be an x squared. Yeah. So it's going to be x squared minus cosine y. Yeah. And then dy over dt, which is et, the same thing. Yeah. Same thing. Now, is this the end? Is this the final answer? No. What do we need to do now? We need to substitute. Yes. We need now to say, okay, it's going to be 2 times x, which is the square root of t squared plus 1, multiplied by y, yeah, multiplied by t over square root of t squared plus 1, plus x squared would just be t squared plus 1 minus cosine of et, like this, and then multiply by et, and we can leave it like this, or if we want, there is some simplifying that we can do. This and this can cancel. So in the end, we get 2t e to the power of t, and then we have the other term, t squared plus 1 minus cosine of et. all of this e to the power of t, and we can just keep it like this. So that is the derivative of z with respect to t in this situation. Okay. I will just leave this. I will not do any more of these things. Chain rule, I just want to do one on implicit differentiation. So I want to show you a little bit, some examples on implicit differentiation, which is here. Here is an equation which defines z as a function of x and y, and I want to find dz over these by the way are the type of equation, the type of questions you will see in the exams. Like we give you an equation like this, and we want to find dz over dx. Okay, so the rule says this will be minus fx over fz. All right, so what is fx here? Fx, if you look at the function, yeah, it's 6xz only, yeah? There's nothing else. And then down, the derivative with respect to z will be 3x squared. Yeah, the first term is 3x squared. The second term will give you 6z squared. Yeah, and the third term will be minus 3y, and that is the answer. So that is dz over dx. We can also calculate dz over dy. It's minus fy over fz, like this. So it's going to be minus the derivative of the function with respect to y. If you look at it, yeah, it's minus 3z. Yes, minus 3z. And down, it's the same as we already have it. It's 3x squared plus 6z squared minus 3y. So it's going to be this. Or these two minuses will give you a plus. So it's 3z over 3x squared plus 6z squared minus 3y. So we have this as the derivative with respect to y, and we have this as the derivative with respect to x. That's it. In 25, again, I want to find dz over dx and also dz over dy. What are they? Okay. What's the first thing we need to do here? Okay, but before we do the rule, we need to always write, you always need to write the equation in the form of fxyz equal to 0. So you always need this form. So basically, you can move the cosine to the other side. So you will get your equation in this form. First. So first you need to do this. Then you need to use the rule now. Now it's okay. We can say dz over dx will be minus fx over fz, like this. Now we can find fx, the derivative now of this with respect to x. So you can see that it's going to give us yz, yeah? Yz, good, yz. And then the derivative of cosine x plus y plus z with respect to x. What do you think that will be? What is the derivative of the inside, by the way? Derivative of the inside? Yeah. Yeah, so it's going to be plus, exactly. Plus sine of x plus y plus z. Normally, you need to multiply by the derivative of the inside, but what is the derivative of x plus y plus z with respect to x? What is the derivative? 1, yes, exactly. So it's 1, so no need to write anything there. And then the denominator, fz, yeah, fz is going to be xy, so xy, again, plus sine of x plus y plus z, like this. So this is going to be dz over dx, and in the same way we can calculate also dz over dy, this time minus fy over fz. The derivative with respect to y, yeah, it's xz, yeah, thank you, xz, and then the other will be the same, plus sine of x plus y plus z, and then fz is already, we already have it, so xy plus sine x plus y plus z, like this. Okay, so that is basically what's in this section. Two major ideas here. The chain rule, yeah, the chain rule which we had a look at, maybe with one variable t or possibly two variables, yeah, and the implicit differentiation, which is the f, yeah, finding dz over dx, dz over dy, or possibly dy over dx if you just have two variables like this. So the rules are there, they're easy to use. You can just, it's a direct calculation, nothing difficult. Okay, so I will just take a few minutes, maybe 5 minutes or so, to close this section and reopen the next one. So take a short break and then we'll come back with the next section. Okay.